Ever wonder how we cool gases to extremely low temperatures, turning them into liquids? From oxygen for hospitals to LNG, liquefied natural gases for fuels, cooling gases in an essential process. But how does it happen? Today we'll break down 4 famous cooling cycles in a simplest way possible. We'll cover Linde Cycle, the basic cooling method, Claude Cycle, more efficient cooling, Claude Cycle, supercooling for liquid helium, and cascade cycle, cooling in multiple steps. Let's dive in. First, we have the Linde cycle, a simple but effective way to cool gases using expansion. Imagine squeezing air into a tight space and then suddenly letting it expand. It cools down. Step of Linde cycle are: first one, gas is compressed, heated up. Second one, it passes through a heat exchanger to lose some heat. Third one, it expands through a nozzle, cooling rapidly. And fourth one, the cold gas is recirculated to cool the incoming gas further. This method is widely used for production of liquid oxygen, nitrogen, and argon. Claude cycle is an improvement of the Linde cycle. Instead of just expanding once, it expands twice. Steps of Claude cycle are: 1. Gas is compressed and cooled like Linde cycle. Second one, some of the gas expands through a turbine, generating extra cooling. Third one, the remaining gases expands through a valve, getting even colder. This process saves energy and is used in liquefying large amount of gases like liquid air for industries. Ever heard of liquid helium? It's one of the coldest substances on earth, but cooling helium is tricky, and that's where the Claude cycle helps. It's similar to Claude cycle, but it uses a special turbo expander that cools helium down to cryogenic temperatures, minus 269 degrees Celsius to 4K. So it is used for superconductor, MRI machines, and space research. The last one is, what if a single cooling step isn't enough? That's where the cascade cycle comes in. Imagine a ladder of cooling steps. First one, refrigerant cool the system slightly. Then second refrigerant cool it even more. Third refrigerant make it even colder. This method is great for cooling methane and other gases with very low boiling point, like the LNG, liquefied natural gases production. These cooling cycles are the backbone of medical oxygen production, space exploration, and energy storage. From the simple Linde cycle to a complex cascade cycle, they all play a crucial role in modern science and industries. Liquid oxygen is used everywhere, from hospital to steel manufacturing, even in rockets. But have you ever wondered which cooling cycle is most used to produce liquid oxygen? The Linde cycle and Claude cycle are the most commonly used for LOX production. Linde cycle is used for smaller plants because it's simple and works well for moderate production. And Claude cycle is used in large scale LOX production because it is more energy efficient and produces a higher yield by using turbine expansion. So if you see a hospital oxygen tank or a steel plant using liquid oxygen, it is most likely made up of Claude cycle. Which cycle amazes you the most? Let us know in the comment below. Like, share, and subscribe for more awesome science video.